Hi, I'm Li Hao. Today I'm going to share with you how you can manipulate AST with JavaScript. Well, what is AST? AST is Abstract Syntax Tree. In short, what that means is that it's a tree representation of your code, right? And then you can have, you can write a C code, Java code, JavaScript code. How the compiler or browser understands it is to parse it in to become an AST, which is a tree representation of your code. Then it understands the meaning of the code, then it can execute it, right? And if you use compiler or like Babel in JavaScript, where you can transform from one code to another, how it works is also using AST, where it will read the code, parse it, and understands it, represents it in an AST, and then an AST is a tree representation, and then you just manipulate the tree representation, and then once you have it, you will convert it back to a code, right? You convert the tree to a code, so you start from code to a tree, so that it's a meaningful representation, and then you manipulate it, and then you convert the tree back to the code. So why do you need to convert from a code to a tree to a code? That's because if you do some pattern matching in the code, you may have some edge cases that you didn't handle well. Some variables that names maybe like a function and things like that you didn't catch, and probably you may misunderstood the code, and your pattern matching will break in some edge cases. But if you convert it to an abstract syntax tree, basically you understand the semantic meanings of the code, understand what it actually means, then you know what is variable, you know what is function, and all the things about the code. Then you can do a manipulation over there. And once you change it, then you can convert it back to a code, right? And you probably will have a similar meaning code, but a transformed code, right? So today we're going to see how we can manipulate AST with JavaScript, right? Over here, I have a playground called ASTExplorer. It's a very good playground that you can play with without setting up anything. So this is I would think is a best starting point for you to learn about AST, as in the terms of in JavaScript, where you roughly know how the AST looks like, right? I mean, it does not teach you how do you generate AST, but it shows you that how AST looks like, right? So you can dip your toes a bit about oh, this is so on the left is your code, and on the right is how the AST looks like, and then probably you will roughly know that okay, this is how it's represented in the tree structure, and then we can do the transformation part, right? And we have libraries that parse the code to AST and generates a code from AST, so that is already taken care of. So probably you just need to write the manipulation part of it, which isn't that difficult, which I was going to share with you. Right, so over here I have a code that say imports T function from I18N. I18N stands for internationalization, so T probably stands for translate or something, right? So you have a function called app, which console logs a T function that calls with a label hello. Over here you have a variable called string that is a result from when you're calling T with a label by, and then you alert that string. So probably this is a string variable that contains a string. So probably this will return as a string, right? So actually I wrote this so I roughly know what it means, or what I'm trying to express. Actually this takes in a label key for your translation. So usually to do internationalization, you use a string identifier for all the text you have. Instead of saying hello world, you use a label something, so that you pass that key identifier to a T function, and depends on the current language that your user selects, it will returns you the current the text in the current language, right? So in English probably it's hello, in Chinese maybe it's ni hao and things like that, right? So this is how it works, right? So why I'm showing this example is that we're gonna see whether we can take in this code and then say that we know that we're gonna generate a code that only will be received by the user who choose to see it in English. And what I want the user to get in the end is probably something like this. I think it does not allow me to write in duplicate function declaration, so I'm just gonna comment it out. But what I want to see is that I'm gonna generate like results I want to see. It's probably like console log and then hello world, right? And in this, bye probably will be bye, nice to meet you, right? So I want it to I want the above code. I want to manipulate the above code, transform it into something like this in the below, right? So, and we are gonna do it together. Right? So you're gonna see like how I'm gonna do it step by step, and yeah, that's what we're gonna do for today, right? So how do we start? So the first thing to start is to actually hover on to the T over here, just like label hello. And I'm gonna see over here it says call expressions and identifier T, right? So this may look cryptic in the very beginning, especially if this is your first time seeing this. But you know, you will have to kind of like get used to it, because I'm not really sure what's the best way to learn about it. But what I can tell you is that different language will have a different kind of tree structure, and it depends on the specs of that language to tell you that what kind of the specifications of that tree, right? And even for JavaScript, maybe different parser that you're using probably end up having a tree that looks slightly different. But there is a specs for JavaScript. It's called a ES tree, which is I wouldn't say a exact specs, but it's a specification or documentation that is written that most of the people follows, right? So in this case, right? So why do I say it's a tree? So you see that a tree structure is like that you have a roots and then you have leaves, and each leaves probably may have even children leaves, and their children leaves may have even like grandchildren leaves. And in this example, I have a file that has properties like type, errors, program, and comments. So and then program is actually like a tree, so like a node of the tree, because the nodes in an AST will always have a type called. So in this case, it's called file. And if you expand this, you will see that program is a type of program, right? So file node has a child called program, which is a node, which has like in the body has 4 other nodes, which is import declaration, function declaration, variable declaration, and expression statements, right? Probably you don't know much about it, but by the name of it, you probably will guess that this is something related to imports. It's related to the function declaration, and this is variable declaration, and this is expression statements, right? And if you hover on it, you probably will see that on the left, you will see that import T is being highlighted. If you hover this, that function is being highlighted. If you hover this, yeah, so on and so forth, right? And as you step down one by one, you see like the source is another node that has a type called string literal, and the source, if you highlight, is this string, and it tells you that value is i18n, exactly as you can see in the code on the left. So we hover on the import, you see the whole statements. You hover on the source, you see the string. What happens to the T, right? So if you try to hover import or specifier, over here you see, okay, so that part of the code is represented within the specifiers, and it's represented by a node called import specifier, right? It's the specifiers of the declaration, and it's represented by a node called import specifier, right? So that's how it is, right? So one thing you can play around with this tree, try to expand and then drill down and see like what kind of node that you have. When you're starting a function, you will see like the identifier. The ID is the function name, and then the body is like the body of the function. And then in the body, you will have like expressions, And expressions, you have a call expression. So call is like calling a function. So you can see the callee is the one that the function that you're going to call is called console log. And then the arguments will be like the T label hello. And if you go to callee, it's like a member expression because you call it console.log. So console is the object, log is the property. So yeah, so play around, get familiar with it. So what we're going to focus here is the call expressions that the callee is the T function and the arguments is the string literal, right? So we're going to transform this. We're going to transform the call expressions when the call function is called T. We're going to transform it to become a string literal, right? As you can see, string literal is just a string and the value is like the value of the string. So we're going to change these call expressions to become to become hello world string, right? So that's what I'm going to do now. So in this Explorer, one thing great about it is that you can also do transform. You can write code over here as well. So I'm going to turn this on. I'm going to choose Babel because I'm using Babel parser. I'm going to choose Babel, which is much easier. But here, I'm going to clean this up. Probably I did something earlier on, but I'm going to clean this up. So this is like a basic structure of a Babel transform plugin, which I do not dwell too much about it. But as you can see, you can define a name and a visitor. What visitor means is that it's an object that you can put in functions or methods. And whenever you visit one node, that function will be called. So what I mean is that, so for example, if I say I want to know about call expressions, because I say that this is the call expressions, right? So I'm going to have a method called call expressions. And I'm going to say console log hi. And if I hit the console, you'll see that the hi gets called 4 times. And that's because you call it once over here, and then once for the console log, twice, and then a third time over here, and the 4th time over here at alert, right? So yeah, that's how a visitor function works. And now the call expression actually pass in something called a path. And in the path, I have access to the current node. So in Babel, you have something called a path, and the path has a property called a node. So if I do over here path.node, you'll see that I have 4 call expressions. So this one, if you expand, you probably see that it looks pretty much the same as this call expression. And the second call expression looks like the second one, which is the T label hello and so forth. I'm not going to expand it, but you can try it out and you can see whether what I say is correct, right? Try it out yourself, please. So as I said earlier, call expressions takes in a path instead of the node, as we can see in the tree. And this only happens in Babel visitor. So this is a very Babel thing. As you can see, we really choose the transform to use Babel to do transform. And what is path? So path is actually a wrapper. You can think of it as a wrapper of the node, which it wraps the node and then it adds a lot of methods so that you have like a lot of helper methods that you can play around with it, that it will apply to the node directly, right? So node is a JavaScript object. You can manipulate it directly, but you can also use path to do it, which sometimes is much easier for you, right? So for example, now I want to see that I want to find this T function, right? So what I usually would do is that I will look at the T function over here. So I call expression, right? Correct. And then if you look at the callee, it is supposed to be like an identifier, and the name of it should be a T, right? If you want to know if this call expression is like the T function that we are calling, then we can do is like if path dot. Okay, so I'm gonna destructure the node so that I can use this node variable instead of calling path.node every time. And I say path.node.type equals to identifier, and node.name equals T, and I'm gonna console it over here, right? So node.type. Oh, sorry. So node is the call expression, right? So it should be node.callee.type and node.callee.name. And now you can see on the console, although it's a bit messy, let me clear this and try to trigger it again. You'll see that we have two nodes now, right? Because we have two T functions that we call over here. So we are one step closer to the actual code that we want to manipulate, right? So next thing we're going to do is that once we find this, we want to replace it to become like a string, right? So one way I like to do usually is that I would come here and, you know, take a look at how this would look like instead, right? So we can compare side by side, you know, like over here, the first expression statement is that the arguments is the call expressions that has callee that we've seen just now, and the code that we want is actually string literal that replaces the call expressions, right? String literal instead of the call expressions. And so now we know that what this is how it should look like, right? So let's see. So node actually, if I'm remember correctly, has a property called parent. Parent node. Well, okay, so that's embarrassing. I believe it's called a parent, path.parent. Right, so as you can see here, now it's pointing to the call expressions of variable declarator. Right, so it's the parent. And as you can see over here, I want that the arguments, the first elements of the parents. So now we get the parent's call expression, and I want the arguments and the first item of it to become a string literal. Right, so what I can do is that, so for example, if path.parent is call expression, let's say path.parent.arguments, the first item, equals to a string literal. So I'm gonna say, since it has an object, I'm gonna say like string. I'm gonna just create my object on my own, right? So I'm gonna say string literal, and then the value is hello world. And now let's see, is it even being, oh, okay, so this is parent.type. And you can see now on the right, bottom right corner, you can see that the code is now transformed to console log hello world, right? And it's let me collapse this, let me open up more, and you can see that, I mean, the AST is an object. You can just play with like an object. You can traverse up and down like parent or children or something, called the properties, and then to assign something else, assign a different object. And a node is also an object, so you assign like a node that has type string literal and value and hello world. Then when you transform it, it will become like a hello world string. That's how easy it is, right? But of course, you might ask me, like, is that what you usually would write? Of course, no, because that's a lot of hassle of writing this. I'm gonna show you a shortcut to do it. But I want to show you this because this is the rawest way of doing it. It's nothing wrong. It's just that probably it's a bit of code. There's more easier way to do it. So I'm gonna show you what now, right? So first thing is usually I wouldn't like reassign this to like create an object and assign it to like arguments directly. It depends on the case, but usually what I would do is is that we are already at this path called call expressions. It has a method called replace with, and you can actually pass this whole thing in to replace with. And it works the same as well, right? I would say that this is more meaningful semantic in terms of code. You can read, oh, you replace this path with another thing. It's much easier to read. It's way better to code it out as well. And I also wouldn't do this, right? I mean, there's a lot of code to write and you might not know like the type, and like this is a very simple example, like a string return. What if you want like a bigger piece of code that you want to replace, like you want to be right a.b.c and then you call in something and you want to use this to replace in, probably you have to create a big object, right? So what I would do over here instead is that I have this function called Babel.template. And over here I'm gonna say hello world. I'm gonna write this instead. Okay, sorry. Yeah, so this I would say that this is much easier to write. So you call a function, so you use something called a tag template literal. So you have a template literal over here and you call it with a tag literal function called Babel.templates. This one gives you a function, and you have to call it to get the node. And that's because you can have some placeholder over here. I can't remember exactly like how the placeholder will look like, but you can pass in a placeholder over here and you can, replace it with something else, right? So you can write a placeholder like a placeholder.c, and then that placeholder value can be b, can be d, can be anything else, right? I can show you the documentation right now because that's arguably the best way to learn about this. So Babel template, and you come here, you see that, yeah, you can call template function literal, and then you can have like percentage sign as a placeholder, and so this returns a function, right? And then you call the function with like, say, import name should be something else again, source should be something else again, right? So I would believe that this would be the easiest way of writing it, and that you have it, right? We have replaced a hello world, t hello world, and t labeled by, right? The next thing we haven't really covered is that this string value should be depending on like the string over here that we have, right? And it shouldn't be that hard once you know this, the hardest part of thing that you have gone through. So probably over here I'm gonna say const translation. So label hello should translates to hello world, and label bye should translates to bye, nice to meet you, right? So what we have here now is that it depends on the string value over here, which is the when we have callee, that's like the node.arguments and the first argument and then the value of it, right? So the key is actually node.callee, arguments, right? Arguments, and then the first item. And then hopefully it's a string literal, so we don't check it. We're just gonna skip checking it. We're gonna say value, right? And here we can go call a translation and then key. So now you have like the full picture of it, right? So we have a function app console log hello world and then string bye, nice to meet you as what we're expecting, and there you have it. Transforming. Manipulating AST with JavaScript, right? So this playground is something that I often frequently visit to play around with AST, right? So the next thing we're gonna explore next is how we actually write this out in a script that reads a file and then does the transformation and control out, right? So this is like the playground that we do. And then the next thing is we can copy this code and we can paste it in our code where we do the setup, where how do we import Babel to do all this, take this in and do the rest, right? So we're going to cover this now. Okay, so here's the basic setup. I have created an empty file over here, which is in the source index.js, and a package.json file. So in this package.json, as you can see over here, I've installed one dependency, which is the Babel core. I installed the latest version for now at this point of recording, which is at 7.12.10. Right, so over here in this index.js is where I'm going to import Babel. And so I imported from Babel core. And then so let's set up the basic pipeline first, right? So as I mentioned earlier, we parse the code into AST, we transform it, and then we generate the code from an AST into the code. Right, so here's the basic setup, which is the first thing is to parse it, right? So we're gonna have a babel.parse. Right now, I can choose whether to use a asynchronous or synchronous method. I'm going to use synchronous so that we can read it one line. We don't have to wait and things like that. But you can choose either one. Any of them is the same. Just that whether it's asynchronous where you have to wait for it, or takes the basic parse would have to pass in a callback function. Async will have to await for it returns a promise, and synchronous will just execute synchronously. So over here, I have to parse the code, and this will give me an AST, the abstract syntax tree. Right. The next thing is I need to traverse it or transform it. So I would need to call something like a traverse, where I traverse through the AST. And over here, I can pass in a visitor, right? And once I traverse the AST, as I traverse it, I manipulate it. And after that one pass of traversal, which is synchronous, then the next part is I'm going to generate the code out of the AST, which is generate. So this I would have to import from Babel generator.default. So here I will generate, I'm passing an AST and then some options. You're gonna skip now, and this will give me results. So results is an object that has a code as well as a source map. Right. So what I can do also is I can console log the result.code so that you can see that it's working. So from here, I start from the code, right? So I'm just going to use the example that we have been using earlier on. Here, I'm going to say, I'm going to replace it with this code. And over here, I'm going to replace it with this visitor. Right. And now, what I'm going to do is going to run this. So let me zoom a bit on my terminal so that you can see it clearly. Okay. So I'm going to say node source index.js. Whoops, hold on. Okay. I think I need to copy this as well. The translation. Okay, I'm going to paste it here right before the Babel traverse. And I'm going to run this again. And as you can see, the code is now transformed, right? So if I want, I can write this code file into another file, right? So say, for example, I'm going to say import file system, import path as well. So over here, I can fs.write file synchronously, get a path, which is, let's see, join dir name, this.js, output.js, let's say the result.code and save it as UTF-8. Right, so now if I run it again, you'll see that there's an output file that is a transform file. Right, so this will be a basic setup for using Babel, where you start with parsing, and then you traverse it, and during traversal you manipulate it over here, and then you generate a code out of that AST. Right, and this is so common that probably there is like another way of doing it, which is a API from Babel, which is called babel.transform. Transform, I'm not sure, transform synchronous. So I can pass in the code over here and then an options over here. And this option is the Babel config options, which includes things like Babel options as well as some presets as well as plugins. Right, so plugins in this case is where we can copy this entire code. So this function itself is in fact a plugin in Babel terms, because so a Babel plugin is nothing but a function which returns an object that has a name and a visitor. And a visitor is the one that the plugin will call and does some will use to call when it's traversing through the file. Right, so we're gonna paste this in over here instead, and over here I'm gonna say I'm gonna copy the code from here all the way over here. Right, and this again returns the result, which now I can comment out all of this. And let's run this. Oops, sorry. Translation is not, oh yeah, sorry. Need to define translation again. So we're gonna copy this out and paste it on top. Right. As you can see here, it behaves the same as well. I think this is much simpler to write. You just use transform sync, and then you pass in the plugins where you pass in everything that you copied over from the Babel ASTExplorer all the way in here, because that is a function, a plugin. And yeah, so as you can see here, you have the plugin as like export default as a file, right? So actually a plugin can also be a file that exports like the plugin. So what I mean is that I can write here, I'm gonna say plugin.js, paste this entire code in, and then over here, instead of saying plugins, I'm gonna say path.join their name, and then plugin.js. Right, right, that's clear, and let's run this. Yep, and yeah, correct. So over here, I need to change it to module.exports equals to this, and it will work, right? I'm not fairly sure why by default export default does not work. Probably because I'm not really sure, right? So a better way is writing it as a module.exports instead of export default ES6 module. So this way, as you can see here, that it's now you just pass in the path to that file, and everything is done over here, and you can have your code transform, right? So now, as you can see over here, we don't have to actually pass all this in as like the code. What we can do instead is we can have something called transform file synchronous. So we're going to use synchronous again, and then we can pass in we can create a new file called input.js, and we can take in all this as an input, save it. I'm gonna change this to the file, the path to point to the input, right? So here is input.js. Let's run this again. Everything still works fine. As you can see here, this has changed, right? Just to show that we are actually indeed importing from, transforming from the input file. We're gonna say this is, we change this function name to hi. I'm gonna save it, run this again. You can see it indeed reads from this file, and output we indeed write our transformed output into this output.js file. Right now we have done several iterations of changing the several iterations of the code. We are now at like almost the best form of we can call this like a code mod, where you can pass in a list of files, right? Probably we can have a list of files to modify. You can have a list of files to modify, and maybe this is one of them, right? And then we can have our plugins over here, which is okay. And then we can write the same file with the transformed code, right? So probably that will be like a code mod where you modify the code in place. So what you can do here is that we can use a loop through the files, all files to modify. And for each of the file, we're gonna say file, and then we're gonna write into the same file again with the result. I'll remove this. Right, so this is like a basic code mod. Right, so you can pass in a list of files that you want to transform, provide a plugin, and you will loop through every file, transform it, and override it in place. Right, so right now if I execute this, you can see now input.js is now no longer having a t function to do the translation, right? So if you look at, okay, let me undo this and come back again. So basically we have already done, I've already showed you how you can use like import Babel and writing a basic setup of a Babel transform as well. So you just need to play around with in the ASTExplorer, and then once you are comfortable with it, you feel good about like the code that you have transformed over here, then you come back with this to paste in your plugin and then run it through, right? So this setup, usually I have it as like a template so that I can reuse it multiple times. I can pass in different plugins and stuff, right? So this is a very powerful template to have if you are the kind of person that likes to use Babel to code mod or transform a code. Source code, right? So so now let's take a look at another thing, which is scope. So what scope is that if you take a look at this input.js file, I'm importing t function from i18n, right? And I'm gonna call it as t over here, right? Okay, I think it's better that we go to the ASTExplorer so that we can see this clearer. So what we're gonna do here is that, so take a look, focus on both the input file and the output file. So if I'm gonna change this like as, we're gonna import t as something else, like say u, and we're gonna use u over here and u over here. You can see that once I change from t to u, this is no longer translated. Right? So if I change it back to t, you can see that it's the translation. If I change to u, it's not. But as you know that, this i18nt is imported as u. You have renamed it to u. So this should be the same function and it should be treated the same. So how do we handle this? And we can't do it nilly-willy, where we can't say once we find that it's U, we're gonna transform everything, like all the U functions to translation. Because, for example, what if you define another function called U inside, and this U, so when you're using U over here, it depends on the scope that it is written in, right? Based on the lexical scoping, U is based on like the block scope. This U will be the one that is being used instead of the U defined at the outer scope, right? You can override inner scope like by defining some variables that shadow across that imported U, right? So you can't go through the file to find all the U's and replace them, right? That may lead to some edge cases, right? That is incorrect. What you should do instead is that you need to find U, all the uses of U that is actually referring to this U that you are writing. Right, too many U's. I'm not sure whether I've lost you, but yeah. So I'm gonna probably change this to S so that I can say U and S. Right, so we're gonna find S. So we're gonna firstly figure out that this is in the import declaration, and it's did importing T by looking at the import specifier where the imported is T, but the local identifier name S. Right? So once we find that T is replaced to S, then we're gonna use the S to find out all the uses of S, and then we're gonna transform them. So let's do it step by step. Right. So the first thing is, as you can see here, I'm going to say import declaration path. So import declaration, right? So the first thing is I need to make sure that it's indeed importing from i18n, the library. So I'm going to say if path.source and then this is like the value is equals to i18n, right? Then I'm gonna log out the specifiers, right? So we're gonna find the specifiers, right? So it's path.node.specifiers.find, and then each of the specifier, gonna say if specifier dot imported dot name equals T, gonna return, right? Gonna return if it's okay, T imported T equals this. So console log imported T. Let's take a look. So we have a node and it's the import specifier. The imported is T and the local is S, right? So if we found this imported T, because it may not be actually importing T, right? If it's like U, then console log imported T may be undefined. You're not importing T at all, right? Then we don't have to do any replacement. So when I say T, okay, so here, once I found it, I know that if then the variable that we are using is called variable is so local. Okay, I'm going to call it local T, right? So it's imported T and the local T may have a different variable name. So the local T is the imported T dot local dot name. Console log again, just make sure that we are on track. Right, now I see S over here. So you can see as we are checking a lot of things, as we are checking here and here and here, the code may leads up to a bit like very nested, which is a bit hard to read. So probably what I'd like to do instead is to, once I see that I'm nested like one layer, two layer, and then I'm going to T, and then probably I'm going to do something again. I would rewrite it to be an early return kind of pattern. So what that means is that I'm going to invert this if case and then return early, right? So if this is not int and then return. And then we're going to find imported T. And if I can't find imported T, then I return. So that I can, you see, I can de-indent this local T like 2 levels out. And this is like much flatter and easier to read through. So once I find like the local T, next thing I need to do is I need to find the scope, and based on the scope, I'm gonna find something in what in Babel we call a binding. Binding is like it's like a binding of all the uses of the variable and the declaration itself, right? So it's like binding this variable that you're using to its declaration. So how do you do that? Is that first thing is that you need to find the right scope. And what I mean right scope is that, so every path has a scope, but the scope depends on the path, right? So the scope within this app function may have like the s defined as this function s, but at outside, like maybe the outside scope may have the s defined as like this s, right? So you need to find the right scope, and we are at the right scope, which is at the import declaration. So basically what we are defining over here, the s we define here, is at the scope that we are looking for. Of course, so I have the scope. Then the next thing is I'm going to call get binding, and I'm going to call local T. So I'm going to get the binding of this variable name. Now you know that why it's so important to get the right scope, because if I'm in this here, any path that is in here, maybe the path of console log, then get binding s string will give me this function, right? So once I get the binding, if you look at here, it's consoling out the binding. There's one properties that I need to use is called the reference paths. That means it's what are the variables that is referencing to what are the paths that is referencing to this variable, right? So I'm gonna say dot reference paths, and now you can see there's one node path. Let me clear this and run this again. All right, there's one node path, and if I remove this or rename this to S1, then you realize that there's two node path, right? Because previously this S was referring to this S, but once I rename this, then this S is referring to my S, then I have two node paths that is referring to this S, right? So now we find that we've finally found like all the S's that is referring to the one that we are importing. Then we can loop through them and replace them, right? These are paths. Paths is the same as this path, except that this reference path most likely is the node itself is most likely an identifier instead of a call expressions, right? So something probably we can do is that once we find the identifier, which is like the variable itself, we'll go up one level to look at the parent, because we're gonna use this variable as this is like the callee, right? So we find out one level, if it's the parent is call expressions, and this call and its callee is this variable that we are referencing, then can replace the call expressions to something else, right? Which is this part of the code. So come here, gonna copy this. So gonna call this. Let's see. Okay, I think I'm gonna use a for loop for path of reference paths. Cons. Okay. So I'm gonna check the parent, which is the if path dot parent dot node dot type Okay, I'm gonna call it parent. Parent is the path.parent. Right, so parent's node, if it's type of call expression, and parent dot callee, okay, node dot callee is equals to path dot node. I'm gonna see whether it's parents dot node. Oh, okay, parent is already a node. So if you want a parent path, then it's a parent path. Yeah, we have 2 exclamation mark, which means that we already find that the parent is call expressions and the callee itself is the same node as the current node. Now, as I said earlier, this again, probably I would end up like nested again. So what I can do is that if it's not this, then I just continue and come here, and then we're gonna come here and we're gonna copy this thing, right? We're gonna replace the caller with the parent with to replace into something like this, right? So this is gonna be path.parent path, and then replace with and the key should be the current path, the parent.arguments.value. Right, now I can remove this, and as you can see here now, everything is transformed nicely. And if we change this to say S, then as you can see, this will be preserved because this S is referring to the S is not the one that's from i18n, right? And this is still transformed. And if I change this variable to say Y, nothing is transformed, and I replace this with Y, then this is transformed, right? So this is why scoping is important, and Babel has helped us a lot by providing helper functions like path.scope.getBinding, and then we can get like reference paths to reference all the usage of this variable, right? And yeah, this will be very useful if you want to replace something that you are importing from, and that you're importing from, and you want to make sure that you are referring to the right variable that you are replacing, instead of like replacing all the variables, right? If you're using something like a regex search to do your code mods, like transform all the files, then probably you might miss this edge case, right? Someone may import it and rename it to something else, and you might not knowing it. But this way, doing it this way, you probably will able to catch all of them, right? You probably will catch the ones that are actually referring to it, not the ones that are, just coincidentally use the same name. So one last thing I want to share with you is that about something called Babel types, and I find that it's will make our code even easier to write and even more meaningful. So it's the same idea as like writing a Babel template, where this is one of those helpers that help us to generate a node from a string. And the one that I'm going to share is called Babel types. Right, and usually what I like to do is I like to import it as T. And this Babel types has a lot of APIs and methods, which I'm not really sure whether like all of them are up to date or documented in the Babel documentation, but I can show you where you can find them, right? So I'm gonna go to github.babel Babel GitHub repository, and we're gonna go to this packages, Babel types repository. And you can find it in the source, right? So if it's a website, it's called Babel types, and it has all this API over here, and you can find them also in like the source folder, right? All these APIs I'm exported as like the public APIs, right? And as you can see here, this contains all the node type, right? So if it's a node type, right? For example, as we know, like import declaration is kind of node. So what is import declaration from this library? Well, this is a factory function for you to create a node, right? So I think we don't really need this because we have learned how to create one using Babel templates, but you can also do it using Babel t.identif like identifier or like some other things, t helper function to create them as well, right? Also over here, there is another function, list of functions called, okay, it's not written here, but for each of them, like for example, import declaration, each of them also have a is and an assert prefix method. This is to check whether the nodes is this kind of type, and you return true or false, and asserts will throw an error if it does not follow it, right? It's following like asserts kind of method, right? So what I'm going to show you here is that over here we do something like parents type is, we check whether the parent type is call expressions, and the callee is whether the callee is a node. We can change this to say the t dot is call expression, the parent, and then the callee, whether it's like a node. Oops, sorry. This should be like an object. Let's see, I think I'm missing some brackets over here. Right, so this probably will improve your readability of the code, right? Whether this parent is a call expression, whether callee is a node, right? I think it's much more easier to read than like and write than like parent.type equals to call expressions, and then parent.callee equals to path node, right? So yeah, Babel types. This would be very helpful for you to do like assertions and checks and validations on the Babel AST node. So that's all I have. If you love what you have learned so far, please give me a shout out on Twitter. And if you have any questions, feel free to DM me on Twitter to ask me about it. I'm more than likely lovely to help you out. And if you've managed to build something out of this, right, share with me. I love to read them. And that's all for now. See you.